Hello, statistics student. This video is still for chapter 10.1 to 10.4, or actually 10.1 and 10.4, comparing population mean by independent as well as matched pair samples. And we were working on example 5, is it? Example 5, yeah, about comparing weight gains, or if there's a weight gain for students from September to April. So instead of comparing sample mean of each one, we're comparing the difference. So compare the difference of each individual difference of is the first person had a weight gain, second person had a weight gain. So we're actually just working on the difference, and we don't have to do the difference ourselves because StatDisk can do it. So all we need to do is do the before and after, right? So yeah. So I'm gonna do it again because last time I figured that my data was like not correct. Before is no, not before, September. Do I have the September? Well, okay, let me do it again. Hypothesis test is match pair, mean match pair. And then show the editor. This is my September, my April weights. September minus April. April, yes. So it is not the same, which is the alternative. Significant level is 0.05 evaluate. So yeah, so the test statistics should be negative 0.1x or negative 0.19, negative 0.19. The p-value is 0.8605, 4 places, and the confidence, 95% confidence interval is negative 3.16 to 2.76. So the difference could be as low as negative 3, as high as 2.7, and you can see that 0 is contained. So let's go back to our notes. Yeah, it's like I think last time we have some error in our data, so we have this is the correct p-value and also test statistics. And you can see that the p-value is exceptionally greater than 0.05. So it is a sample that agree with X0, meaning that there should be no difference. And it is not a rare sample, it's not a significant sample, so we would use the wording not sufficient evidence. No, not surprising, not sufficient evidence. And then because our claim is actually equal to 0, we're claiming that there is no difference, right? And our claim is actually in the null hypothesis, so we use the wording reject, not sufficient evidence to reject, because the claim is waiting to be rejected, but there is not sufficient evidence to reject it, so that there is no mean weight difference. So conclude that they are actually no difference. And this can be confirmed from the confidence intervals of negative 3.1 to 2.76 that contains 0. So we are 95% confidence that the mean change in weight is difference. It could be as low as 3.16 or a decrease of 2.76, but because it's 0, there could be no significant difference. And so both the confidence interval and the hypothesis test point to the same conclusion. Last one, which is very popular in hypothesis testing for testing if a particular treatment is useful. So this is the last example is about a study was conducted to investigate the effectiveness of hypnotism in reducing pain. So they have a treatment that is introduced. Instead of having a control group, they just have people that record their pain level before and after the treatment. So after you hypnotize them, which is supposed to relax them, so make them less, become less stressful, and maybe it reduced the pain level. So a higher level corresponds to greater level of pain. So if they have higher pain and after the treatment they have lower, that would be effective, right? So look at what they want to do. Conduct a hypothesis test to test the claim that hypnotism treatment can reduce pain. Now, when we say reduce, lower, we kind of think of less than, right? So should I have my claim being before is less than after? That doesn't make sense. If before pain is less than after pain, that means your pain level increase, right? So let's look at, so it should not be a less than. So let's look at how to set it up. So now, first of all, we have to look at whether a sample is dependent or independent. This is a dependent sample, obviously, because we have data. Each pairs is from the same patient. You can actually find out if the patient actually had reduced the pain. So the first one actually did not reduce. The second one reduced a lot, right? The last one, you can see that initially the pain level is 11.6, now it reduced to 2. So in order to see if they're effective, instead of comparing the mean of the before and the mean of the after, it's actually better to see if each one actually had a decrease. So that's the idea. This particular way of comparing, if you have a lower pain level, is more accurate. So when you do treatment tests or experiment, dependent samples is better than you just have two group of patients, one is before, one is after. So the samples are dependent. So we define D is always the first minus the second, before minus after. Now, if it is effective to reduce pain, your before should be higher and your after should be lower, right? So when you subtract before minus after, higher pain level minus lower pain level, you should have a positive number, right? For the hypnotic treatment to reduce pain, these should be positive as a claim. So I should write the claim as mu of D is positive for it to reduce pain. The null hypothesis is mu of D is 0, and the alternative for H1, sometimes it's called H1, this is actually HA, should be is positive, so that this is the claim. It has been reduced in the after, right? So we're ready to put it in. I have put the before and after instead this. Reset it. Before, after, do I have enough? 1, 2, 3, 4, 5, 6, 7. Oh gosh, I think my data is screwed up. So I'm gonna delete them. Delete the before and after. Before, after. And then I'm gonna add it back. Okay. Add column, add the blank column. No idea what happened. And then rename them. Added them. 5 is before and 6 is after. Okay, I have my data in a Excel spreadsheet, so not this one. Yeah, so this is before and after. So I'm gonna copy and paste again. So I like to keep all my data in Excel because it's easier to just copy in. So Control V. Right, so these are 1, 2, 3, 4, 5, 6, 7, 8. It's an X sets of data. Earlier it was like 4, I don't know why. So we're going to do a hypothesis test. Is a match pair, mean match pairs, right? We are comparing that the mean difference is less than. Before, is it greater than? Let's look at the, should I do greater? Oh, it is greater than. It reduces it, but that means when you subtract them, it's positive. And so the first is before, the second sample is after. So remember, this is the sample 1, sample 2. The position is important. And then after, I didn't select it. So yeah, 0.05, evaluate. So the They tell you that the mean difference, this is D bar, the mean standard deviation, the difference standard deviation is 2.9. So some question asks for it. So test statistic T is 3.04. 3.04. So this, and then p-value 0.0095, right? So it seems like a very rare sample if there is compared to the null hypothesis of no. And then you have a confidence level of 1.17 to 5.08. Copy all this down, put it back. 3.04, 0.0095, right? And then we have this 1.17 and 5.08 difference in pain level. So of course the main conclusion from the hypothesis test is using the p-value. We can see that this is a rare sample because it is 3 standard deviation away from no difference, right? The difference is quite big. How big is the difference? The mean difference is 3 points. So every one of them, on average, their pain level decreased by 3 points. So some decrease more, some decrease less. This actually increased actually, but on average is 3. So which is very far away from 0, which is the null hypothesis that say that there is no difference. So because it's a rare sample, we say there's sufficient evidence. And then because our claim is in HA, the alternative, so we say sufficient evidence to support, we use the word support, the claim that hypnotism treatment can reduce pain level. They can. We also get the confidence interval. They're all positive. Positive means before is larger than after. So when you subtract them, because our difference is before minus after, so this is higher, this is lower. And they're all positive. That means afterward, your number is lower. So that we can conclude hypnotism treatment can reduce pain. And you can see that the conclusion from the hypothesis test and the conclusion from confidence interval are both the same. They agree. So dependent sample, remember to click in statistics, use hypothesis test, mean match pairs. There is no way you can enter some sample statistics. So they are always waiting for the sample before and after, or what is that for sample 1, sample 2, which is matched. If it is a hypothesis test, 2 independent sample, you have a choice of using data or use summary statistic. Now, let's check. If I use data here on our before and after, let's see what happened. Let's say before here, and then after is here. You can see, and then I evaluate. You can see that the p-value is not 0.009, is 0.02. Test statistics is not 3, it's 2.6. So although you can say, well, 0.02 is still less than 0.05, so saying that this is maybe effective. Oh, no, actually it is not equal to, right, which is what? Greater than? I forgot to do the alternative. So you can see that the p-value is different. So if you use a wrong selection of independent versus match pairs, you would have a wrong p-values. Okay. Although maybe your conclusion is the same, but the numbers does not agree and you will lose point. Okay. So that's all for comparing mean. Most important is to know if they are dependent and independent sample. Dependent sample is very easy to detect because they usually tells you it's from the same person or same group, before, after, or like this case, this one is not, okay. It's the same students from different time, or twin. They're measuring, the difference in response of 2 treatments, something like that. Okay, so that is the end of 10.4.